The channel. So today we are going to understand the today Leetcode problem. We have 3341. Find minimum time to reach the last room, right? So today we are solving a new Leetcode problem in today contest. So we have to find the minimum time to reach the last room. It's a grid based problem with a twist. So each room can only be entered after a specific time. So what we have given, if you pause this video and if you go through the problem statement, you will see that we have given n cross m dungeon grid, right? And you start from 0 0, right, at time 0, and it takes 1 second to move to the adjacent room, right? So if you want to move to the adjacent rooms, you have to take 1 second. But here is the catch. Each room has a minimum time you must wait before entering. Okay. So for example, if you move at 1 0, let's suppose if you are moving to 1 0, right, equal to 4, you can only enter that room at time 4 or later. If the move time for example, for this move time, I is 0, I is 1 and j is 0, let's suppose, right, means we want to move. If the move time at 1 0 is equal to 4, right, so you can only enter that room at time 4 or later, whatever the time we have given at this point, right? So let's suppose if we are talking about this one, so we are at where? At 0 0, right? So at 0 0, what we have given? We have given what? 0. But when we come to 1 0, what we have at 1 0 is 4. So if you want to enter that room, right, then you can enter at time 4 or later. You cannot enter before that. So this is the minimum time you must wait before entering, and that is why these explanations are given. Okay, so you must pause this video and go through the problem statements. Okay, so let me read this statement for you so you will understand. Okay, so the question is saying that you have given a dungeon with n cross n rooms arranged as a grid. The 2D array move time of size n cross m, the same size, at value ij, represents the minimum time in second, and you can start moving to that room. So you start from 0 0 at time is 0 and can move to the adjacent rooms. Moving between the adjacent room takes exactly 1 second, and so we have to return the minimum time to reach to the n-1 and m-1 room, right? So two rooms are adjacent we have given, and so you have to reach to the that room, right? Means from the top top left, right, from the top left room to the down down, you can say bottom left, you have bottom right, you have to reach, right? Means you are given a dungeon, a grid of room like a maze, and each room has a time restriction. You can only enter it after or at a time mentioned in the move time, right? So whatever the time we have given, right, these are the times we have given, right? So a grid of rooms we have given, these are the grids, and this move time we have given. So each room has a restriction and you can only enter it after or at that time mentioned in this grid, right? So these values are given at that time, you can enter only. Okay, so you can start at the top left, right, room at 0 0 at time 0. Okay, so if you go through the grid, right, let's suppose grid. So if I'll take any of these examples, okay, let's suppose I'll go with this grid. So if you will start from here, you will come till here. Okay, so you can start from, you have to start from here and you have to come to this point, right? So like that it is saying. So you can start at the top left room, that is 0 0 at time is equal to 0, and you want to reach at the bottom right room n minus 1 to m minus 1 room as fast as possible. But you can move up, down, left or right, but each room takes 1 second exactly. But you can't enter a room before it allowed time that we have given at a certain index ij, right? So this question belongs to a real world analogy. So just think about a museum is there where each room has a time lock. So you are allowed to go from one room to the next only after its locks are open. When the lock opens, right, means when the current time is at least at the certain time we have given. For example, at 1 0, right, means 4 we have given. Until we reaches to the 4, right, the time is before 4 you cannot enter, but after 4 and after that 4 you can enter. So when the current time is at least that time, so you can start at the entrance 0 0, right? You can start, right, at time 0 and want to get to the exit n minus 1 m minus 1 as possible, as soon as possible, right? You can do, means the we have given 0 0 4 and 4 0. Just down, you write just down from here 0 0 4 and 4 0. Okay, what I'm trying to say, I can write like this. So let's suppose we have given 0 and then we have given 4, then we have given 4 and then we have given 4, right, like this. So you can enter at entrance 0 0 and want to get to exit at n minus 1 m minus 1 at this position as early as possible. So let's understand, let me increase little bit. Okay, so let's understand this position. So this position is that at time 0, so you are at 0 0 and you can move from here. But if you go to the 0 1, that opens at time 4. So here time 0, but here is time 0 4. When you talk about 1 0, it's open at time 4 and so on. So you have to wait until time 4. So time 4 means move from 1 0, right, 1 0, move to 1 0 takes 1 second. From here to here it takes what, 1 second. So now at time 5, right, you can exit. If you want to exit from here, right, it will take 1 second. So now after exit this, it will become what, time 5. So at time 5 you are at where, at after this you will reach here, and so you will reach to, because this is also 4, right, so you will reach to 1 1. So 1 1 is also taking from here to here, it take 4, then 5 and then 6, right, and that is why the answer was giving 6. So it was saying at time 4 move from 0 0 to 1 0, right, means at time 0 0 we are moving to here, right, so it's take what, t equal to 4 now, right, and from here you can move, right, and so from here to here if you'll come, right, then what will happen, at 1 0 it will take 1 second, right, so you will reach from here, right, at t equal to 5. So from 1 0 to 1 1 it take 1 second. So from here to here it will take 1 second. So 5 plus 1 is 6. So it will take now total 6 second to reach here, and so you are getting 6, right. So even if you are physically adjacent to a room, you can't enter it until its time log opens. So the strategy is track the current time and then wait if the room you want to move to isn't yet open. So always choose the next move that leads to the fastest route. Okay. So I hope you understands this problem, right? Because without understanding the problem, you cannot do the implementation, right? Right. So you are given a 2D array, you are given a 2D array, or you can say grid, right? And where each cell ij tells us the earliest time, and in this room we are allowed to enter that room. We can move to any adjacent room, up, down, left and right in 1 second. But the challenge is we can't enter the room until the current time is at least at the move of inj, right? So this is the shortest path problem with the time constant, and the best fit algorithm is this Dijkstra algorithm, because the movement cost is uniform. It is taking 1 second, as you can see, and each move has a minimum start time, a start time constant, right? So we will use here the minimum heap priority queue to always explore the room with at least the current time, and so we'll start implementing here. So there is one catch is also here. Okay, so some people will also say, so why you are going to use Dijkstra algorithm, right, and not the BFS, right? So this is a great question, guys. If you are thinking that why you are using Dijkstra and not the BFS, so sometimes we confuse in the interview room and deciding which is the best for this problem, right? So you have to understand the problem statement, and based on that you have to use Dijkstra or BFS, right? So in this case Dijkstra is best, not the BFS. Why? Because BFS means breadth first search, right? So breadth first search works best when all the moves that we have given are having all the moves, you can say, have equal cost, right? But there are no constant like waiting time or you can say a time log, right? So if there are no constant like waiting time or time logs, because we have only given the move times, right? But there are no constant like waiting time or time logs. Okay, but in this problem each move has what we have, a fixed cost of 1 second, right? But a time constant we have given, right? Time constant we have given, and you can't enter a room before the move time we have given I at inj, right? As you can see here, right, that we have given. Okay, so you might have to wait before entering to a room, and BFS can't handle this waiting logic easily because it assumes you move immediately from here to here and after that here to here, right? It is, we don't have any waiting logic. Okay, and so we can't use the BFS, but Dijkstra we can use because this is ideal when you want the shortest time distance. Some moves have a delay or constant like our case that we have given. So if the delay and constants are given, right, like we have in the our case, so it uses a priority queue to always pick the earliest available room, and it handles the waiting time logic perfectly. Okay, so the best choice will be our Dijkstra algorithm because it correctly handles both waiting time for move at inj, and we have to picking the room reachable at the earliest valid time, right? So it is best to use the Dijkstra algorithm, right? I hope you understanding this video right till now. So let's go to do the coding. Okay, explain it here. Okay, so let me zoom little bit. Okay, So as you can see, right, the first of all what we should do, we should initialize all the distances as infinity. Okay, so what I will do, I'll create some infinity constant here, right, because we have given in the statement. Okay, so define the large constant that represent the infinity for initialization. Okay, and for that you have to do you write as a separate variable. Okay, inf. So for now ignore it and understand the rest of the part of the code. Okay, so we have to start from 0 0, right, that we have given, right, and so the first cell is 0 0, and you can start from there at time 0 0. So we have to set that, we have to set this distance at 0 0 and e is equal to 0, right, and for that what we will do, first you will get the length of n and m, you will get number of column, number of rows and columns, you get n cross m, and the first step we have to do to initialize the array with the infinity, so that we will do, and then we will create the distance array, right. So distance array will contain n and m of size, the same size that we have in the move, right. Then the next step we will create a visited one, so we cannot go again to check the same cell, right. So if we have already visited the array cell, so we can avoid revisiting the cell again, and we will not go in the infinite loop. Okay, after that we'll create a loop, right, to fill all the elements. We will define, we will fill the each row, you can say, with infinite. Okay, infinity, right. So this is our basic things we need to do before going for the rest of the code. Okay, next what we will do, so next we will use a priority queue. So priority queue is in Java util package, so use the priority queue. I think here we will not require these things, but if you are using on Eclipse, you have to install Eclipse or Notepad, then you have to write from the package of utility util packager. Then you will use the priority queue, you will pass the state, we will create a class for this. I will show you here. So as you can see, we have a state class, right, that implements comparable, and will take x, y and distance, right. So this is your constructor, and will compare these two distances with this, and so we can store the position of the current position, and we will find the shortest distance. So when you are writing the priority queue, you just create a state, right, and then use the priority queue to find the minimum heap, and we will calculate, we will use the minimum heaped priority queue to always expand the shortest time cell. Okay, this is the purpose. Then what we will do, we'll add the first step, because we are going to start from the first cell. So first cell is x is 0, y is 0 and time is 0. So the position and the time both are 0, so all are 0 0. Then we'll have distance at 0 0, we will set as a 0 0, because we are starting from 0 0 at time 0, so we have to set this to. Further, we can move either down, what direction we can move, down, up, right and left, right, and so that the direction for the down is 1 0, up for minus 1 0, right for 0 1 and left for 0 minus 1. Okay, so these are the directions, 4 directions, and we'll move all the direction from each cell. So Dijkstra algorithm loop we are going to create, and as you know, we will go this loop until the priority queue is not empty, right. So we have created the pq and we have added the first cell, right. So from the first cell we can move any directions, right, any 4 directions we can move. So what we will do, first of all we'll get the current cell data, and that is called current. So pq dot means from the priority queue we will poll the current cell information. So from the current cell we can move to all other cell, right? And so we'll check if this cell is already visited, this room is already visited. Cell means room. So we are in the current room at 0 0 from here. So if the cell is visited, we will skip it. So for that you will just check visited at current x current y. If it is coming true, right, so we'll return. If it is visited, right, means continue. Means if it is visited means continue. So if you remember, visited we have taken boolean and by default it is false. But if this is true, we'll continue, means we have already visited. If it is not visited, just mark it as a visited and continue the exploration of the four neighbors. So we'll make the four directional loop and to explore all the neighbors, right? Up, down, left, right, we will move. Okay. So we'll add, for the x we will add 0 and for the y we'll add 1, right? We'll get nx and y. Now we have to make some boundaries so we will not go out of the grid. So we'll check nx is less than 0, right? So why we are doing here, you understand first, right? So for each valid neighbors, right, we will calculate when you can move there or not, right? And then we will find the, we will check the max of max between current time and the move time that we have given, right? Means move time we will get from where, this is the thing, nx at nx at nx and nsy. So when we call the you can see here, right? So when we write move time nx and ny, right, so we are trying to calculate when you can move there, right? So we'll do that. So first of all, create the boundaries condition, check, otherwise you will go out of the boundary. Then we'll wait for until we'll move to this condition, and then we'll do +1 to enter that room, right? Because entering in a room, it will take +1 second, right? And so we are doing. So first find the distance, max distance, and do the plus, right? So move at this, there will be some time, right? There is some time is given, right? So current position have some data. So for this distance, let's suppose this is coming for the first time, right? So the current time is 0, at 0 it is 0 0, right? So it is 0. But when we are moving to the next point is at 4, right? So it is 4. So 0 and 4, which is max? 4, right? And we are doing +1. So it will, the arrival become 5. Remember, I was talking about the example 0 4 4 4, right? So where we are moving to 0 to 4, right? When we are moving from 0 to 4, so this is 0 and this is what, 4. And so the arrival time is becoming what, 5. Automatically it become 5. Then the last it is coming from, it is taking 4 time 4, then it from 5 to 6 it is coming, and final we are getting the final just 6 answer, right? So that is happening in this to do. Now relax the edge if we found a better, or you can say smaller arrival time. So how we are going to find? So we'll just check the arrival. If arrival is less than nx distance at nx ny, right? So this arrival time is less than this value at this distance, right? Now we will set the arrival value. Okay, so arrival value will get set because we need the minimum one, right? If it is saying more time, so we can find the more one, but we need the minimum one, so we are getting the minimum, we are updating the distance. Okay, because at this value, at this index, right, nx and ny, if the value is more, right, means we have to update that value. So now add pq dot offer. So if what we are trying to do here, right? So if let's suppose if we will calculate you can move or not, right, means till that we are getting, right, arrival. Okay, so you got the arrival time. Now you checking the arrival, right? If arrival is less than the given distance, right, means if that is faster than the previous, right? So we will update it and we'll post it to the queue, and that is why we are using pq.offer. We are pushing to the queue. Okay, and the same thing will keep repeating for all the directions. So we'll repeat until all the reachable cells are processed, and we'll return dist as n-1 m-1. This is the required thing that we have to return as the shortest time to reach to the bottom right from the top cells, right? So let me zoom out so we can go through easily. Okay, so this is very simple problem, right? Just you have to take care of few things. So I think you understand this part, because this is the problem statement, right? Only we have to create the distance and the visited one, because we are using the priority queue, and these are the to fill the array, distance array, and this is the priority queue. We will add the first cell, then we are defining all the directions, then we are going through the etc algorithm loop, where we will visit all the directions and will update the priority queue, and finally we'll update the distance at values, right? So if you talk about the complexity, if you will talk about the complexity, then we are getting O of n into m log nm. So it is taking n of n into m cells, right? So if you talk about the time complexity, right? So if you talk about the time complexity, right, you will get what? O of n into m into log nm. Okay, you can keep it, you can keep in both like this, like this. Okay, so the time complexity is n into m, right, and log nm. Why? Because there is n into m cells, so each cell may be pushed into the heap once, right, and the heap operation takes log nm, right? This time is taken by the heap, right, heap operations. And if you talk about the space complexity, this is your space complexity. Sc we will write is this. This is your space complexity, because we are using the distance and visited and the heap storage, right? I hope you like this video, guys. If you have any doubt, please ping me in the comment box. I will be happy to explain there, and let me know if you have any suggestion for this video. Thank you for watching this video.